Okay, so good afternoon, everybody. Um, I'm gonna finish chapter one today, and then I'm gonna start chapter two. Let me, yeah, okay. So, as I explained last time, guys, I told you there is something called flags, okay? And that's what you will see in the coming lab. Flags, every flag is just one bit, okay? If it is one, so it is telling you something. If it is zero, it is telling you something else. This is number one. Number two, these flags are updated automatically, okay, after executing every instruction, okay. So last time I explained these four flags actually. These two flags, zero flag, I told you, after you do certain operation, if the result of the operation is zero, so this flag is going to be one, okay? Otherwise, this is zero. So this flag can tell you if the result of the last operation is zero or not, okay? The second one, it is called negative flag, okay? And this one can tell you if the result of the last operation or the last command is negative or not, because this one is one if the result is negative, otherwise it is zero, okay? And I told you these two flags are mainly used for comparison. When you compare, as I said last time, you have to subtract, and then after subtraction, I'm gonna look at this flag. If the zero flag is one, that means the two numbers are equal because the result is zero, and so on, okay? So in the coming quiz tomorrow, I will give you, I just wanna make sure you understand what I said, very simple. So I'm gonna give you some numbers, and then I'm gonna tell me what are the flags, the values of the flags, okay? You will see right now, I'm gonna give you some examples now, just to make sure you understand. Very easy. All what you have to do, just look at the result. If the result is zero, this one is one, otherwise it's zero. Very easy, right? Same thing here. Look at the result. If the result is negative, okay, that means, as I said before, the most significant bit is one, okay? So that means this one is one, okay? So I can tell you a trick here. The trick is this one, you can just copy the most significant bit here. Copy it here. So this one should equal the most significant bit. That's true, because if the most significant bit is one, it is negative, and this one has to be one. Yes. So this is very easy. Now, also last time I explained what I mean by overflow when you add number plus number and you want to store the result in a byte, okay? However, the result is bigger, you need more than a byte because byte has a limit. That's what I explained, what I mean by overflow, okay? So if you add two numbers, okay, and you want to store the result in a byte, but actually the result is more than 255, which is the limit for unsigned numbers. In this case, that means there is overflow. And as you will see in the examples today, the number you get here is not a correct number for sure. It's not correct because we don't have enough space, right? Anyway, so I told you we have, for overflow, we have two flags, okay? One is used, which the carry flag, okay? This carry flag should tell you if there is unsigned overflow or not, okay? So if you consider the numbers unsigned, and then the carry flag is one, that means there is overflow. Otherwise, if there is no overflow, the carry flag should be zero, okay? So when I give you numbers and I ask you what is the value of the carry flag, how can you do it? Very easy. All what you have to do, guys, as you'll see in the examples right now, do the addition, normal bit by bit addition, and then if there is a carry here, this carry should go to the carry flag. If there is no carry, this one should be zero. And also remember, if there is a carry here, that means there is overflow for sure because I need more space. So for example, look here, guys, this is a very good example. I want to add 255 plus 1. The result should be 256, which is this number, by the way. So this number is 256, okay? However, because I'm going to store the result in a byte, again, The carry is not a part of the result. So this is the result. That's why I'm gonna get 0, okay, instead to 256. That's because I need more space. So anyway, so always if there is a carry here coming from here, that means there is unsigned overflow. And again, whatever you get here, just put it in the carry. If you get a carry, put here 1. If you don't, if there is no carry here, just put 0. Okay, very easy, right? Now the last one, we have another flag. This flag is called overflow flag. Okay, this overflow flag should be 1 if there is overflow in case that the numbers are signed. Okay, and there is, if it is 0, that means there is no overflow and the numbers are signed. Okay, so very easy. What I'm saying, guys, very easy. You add 2 numbers. Is that okay? You want to know if there is overflow or not. Very easy. If your numbers are unsigned, your friend, the carry flag, is going to tell you if there is overflow or not. If your numbers are signed, you should not ask carry flag, ask the overflow flag. Okay, so now how you calculate it? When again, I said many times before, in reality you don't need to calculate anything because all these flags are calculated automatically. That's what I'm saying. But if you have some, if you have numbers and you want to know if there is overflow or not, in case of signed overflow, okay, how can you know? I made it very easy. All what, look here, guys, the signed overflow flag always 0, always, except in 2 cases. Except in 2 cases. One case, if you add positive number plus positive number and you get negative, like this case. The last 0, 0, I got 1. So this is positive plus positive, I got negative. Or negative plus negative, I got positive. Okay. In any other case, it should be there is no overflow. Is that okay? I will just want to make it easy. So all what you have to do, guys, when I ask you what is the value of the overflow flag, very easy. Look at this case. 0, 0, 1. Yes, overflow is 1. Okay. 1, 1, 0. So overflow is 1. Right? Otherwise, it is 0. Okay. By common sense, look here, guys. By common sense, this is a positive number and this is a positive number. So when I add them together, there is a risk of overflow because the number is going to get bigger. Same thing here. This is a negative number. There is a negative number, right? This is a negative number. If you add them together, there is a risk of overflow because the number is going to get bigger. However, if one number is negative and the other one is positive, there is no risk of overflow because what you are going to get is going to be smaller than these 2 numbers. So if these 2 numbers are already enough to be in bytes, for sure the result should be enough. Okay, makes sense, right? So what I'm saying is that if the sign is different, there is no risk of overflow for sure because the number is going to get smaller, not bigger. Anyway, so I'm done with this chapter, but I want to give you examples. I have here some examples here. Also, let me go through the slides. I think I explained everything. Yeah, I explained. Only we're going to have some examples here. I want to teach these examples, okay? Just 1 second, let me get the pen. Okay. Look here, guys. Let's see this example. Okay. Here, I want to add this number plus this number. Okay. So this is just normal binary addition. 1 plus 1 is 0, and we have 1 here. 1 plus 1 is 0, and we have 1 here. 1 plus 1 is 0, and so on. And then we have a carry here. Okay, guys. I'm gonna repeat it again. I know students are confused here. Where is the result? Okay. Yeah, this is the result because I'm adding byte plus byte, and we want to store the result in a byte, and we have a carry, right? This is maybe different from adding numbers in digital system because here I'm adding byte plus byte, and I need to store the result in a byte. You got what I'm saying? So this is the result, and one is going to go to, for sure, because there is a 1 here. After I add, there is a 1 here. This one has to go to the carry. Anyway, let's look at the flags here. Okay, one by
What
one.
is the V flag?
Where is the V flag?
Yeah, what does the V stand for? Like which flag is that?
This is the overflow flag. This is the signed one.
Oh,
Yeah,
that's
you
right,
got
because
them.
the other one was I put down as an O.
Yeah,
That's fine, never
sometimes
mind.
sometimes I make it OV. I'm sorry. Yeah, sometimes, but yeah. So this is the overflow one. Okay, the signed overflow one. Okay. So let's look here. Number one, let's look at the zero flag. This is the result. The result is zero, right? That's why the zero flag has to be one, right? Okay. And now let's negative flag. This is the result. Okay. The result is not negative. Okay. So it is zero. I told you very simple way. You can just copy. You can just copy the most significant bit here. That's it. Okay. Now look at the carry. Okay. Is there a carry? Yes, there was a carry here. That's why it is one. Okay. Now look at the overflow or signed overflow flag. This one. Look here, guys. I'm not gonna even think about it. You know why? Because this is negative number. This is a positive number. You got what I'm saying? So no overflow. I told you overflow can only happen if this is positive or negative. So there is no risk of overflow. Okay. So what I explain now, how can you calculate this? Okay. Now let me interpret this answer. So now, because the carry is one, what it means? It means there is unsigned overflow. That means if you consider your number unsigned, the result is not correct because there is overflow. Okay. That's what I did. If you look here, guys, this number is 255, as you see here, 255. Okay. And this one, let me make, yeah, laser maybe. Okay. So this number is 255 and this is 1. So I added 255 plus 1, I got 0, right? Which is not correct because there is, because of this one here, because there is unsigned overflow. Look now at V here, V equals 0. What it means? It means there is no signed overflow. So if you consider this number signed, you are okay. The answer is correct. So let's see. Yes, this is minus 1 and this is positive 1. If I want, I got 0. Yes, that's correct. Minus 1 plus positive 1, I got 0. Is that okay, guys? Any question? I'm gonna give you two or three more examples, but I'm gonna repeat all what I said, but on different numbers. Any question, guys? Okay. So let me see this example. Same thing as I did before, just normal addition. 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, and so on. So I added this number plus this number, I got this one. Okay, let's look at them one by one. Let's start with the easy one, the zero flag. Okay, so zero flag should be 0 because the result is not 0, right? That's why it is 0. That's great. Look, what about the negative flag? For sure, this is a negative number, or as I said, you can just copy. You can easily copy. You can copy the last bit here. Okay, the sign bit, you can just copy it here. Copy it here. So this is a negative number. That's okay. Now, when I did the addition, was there a carry here? No, there is no carry when I did the addition. That's why the carry is 0. Is that okay? Now, how can I calculate the overflow flag? Look, don't think about it. This is a negative number. This is a positive number. There is no way for overflow to happen, right? So that's why it is 0. Now, let me interpret the results. So this result is telling me, these results are telling me, if you consider the number unsigned, there is no overflow. In case of signed, there is no overflow. So always the result is correct. And that's what I did. I converted this number. This is minus 86 plus 85. I got minus 1, which is correct, right? This is 170 plus 85. I got 255, which is correct. Any question, guys? Okay. Let's have two more examples, and maybe that's it. Okay. Yeah. So let's look at this example here, another example here, guys. Again, I'm going to do normal addition. 1 plus 1 is 0. And then we have 1 plus 1 is 0, 1 plus 1, and so on. So this is just a normal addition, right? And this is the result. Okay,
That's what I'm gonna do tomorrow. I'm very easy instructor. I'm telling you what will be in the quiz. Just study it, just understand it. So what I will do, I just want to make sure you understand what I'm explaining right now. Very easy, right? So what I'm gonna do, I'm gonna give you something like that, but for sure it's gonna be different numbers, not gonna be the same numbers. Okay. So I'm gonna give you something like that. I'm gonna ask you what are the values of the flex. Is there overflow or not? Okay, and so on. I'm gonna ask you that. But anyway, so let's how to do it. So I just did binary addition, normal addition, and now let's look at the zero flag. Zero flag has to be zero. Why? Because the result is not zero, as you see here, because we have one here. The result is not zero. Makes sense, right? Look at the negative flag. For sure, this result is negative because here, or you can just copy this one here from here to here, right? So any question here? That's very easy, right? Okay. Now look at the carry. When I did addition, there was a carry here. Here, no, there was no carry. That's why it is zero, right? Look at the overflow. Look here, guys. This is a positive number. This is a positive number. I got negative number. Yes. So there is signed overflow. Okay. Now let's interpret the results. If you consider this number unsigned, so the addition is done correctly, no problem. But if you consider this number signed, okay, the result is not correct because there is signed overflow. Let's see if that's true. Okay. In case of unsigned, this number here is 127, and this number is 1, and this number is 128. It's correct, right? If you add 127 plus 1 should equal 128, so you are okay, right? Now, if you consider these numbers signed, this one is positive 127, this one is positive 1, but this one is negative 128. For sure, this is not correct because this flag told me already that. Okay. Any question before I give you last example, guys? Again, don't be shy. If you have any question, just unmute your mic and ask me. Okay.
So if
Yeah,
we're
sure.
going to do addition with two numbers that are unsigned, will it still show the V flag as being 1 because there was a carry on there was a signed overflow, but we just don't ask for the V flag?
That's a very good question. Can you please say it again?
Okay, so if you have two numbers that you're adding, 2 bytes, and they overflow, and it's unsigned, and the machine thinks you're doing, doesn't know what you're doing, like it's just, well, let me start over. Okay, so
No,
have,
this is sorry for interrupting you, but this is a very good part. The machine does not know if my numbers are unsigned or signed. This is a very important point. That's true. The machine doesn't know. That is why the machine is going to give me 2 results. If you, programmer, during writing your program, if you consider these numbers unsigned, you have to go to the carry flag. If you consider the number signed, you have to go to the V flag. So the machine is going to give you 2, is that both of them signed or unsigned all the time, because the machine doesn't know if this number signed or unsigned.
so it just depends on what we're asking for at that point.
It depends when you write your program.
Yeah,
if you consider your number unsigned and you want to know if there is overflow or not, you have to write instruction to check this one, not this one, right? But the machine is going to give you both. Is that clear? I think I made it very clear in the very beginning. Signed or unsigned should be handled, should be considered by the programmer. I made it very clear in the very beginning. Is that okay? That's why it's going to be clear in chapter 2. In chapter 2, I'm going to give you 2 sets of instructions. I'm going to tell you, when you write your program and you consider this number signed, you have to use this set of instruction. Okay? Or otherwise use this set of instructions. So this is something you are going to handle when you write your program. Is that, I know students are always confused in this part. Okay, guys? So don't ask me, are these numbers signed or unsigned? Is that okay? It's up to you. Maybe in one program, I'm going to consider it unsigned, and then I have to look at C. Or I'm going to consider it signed, and in this case, I have to look at V. Okay, guys? Is that clear? Have I answered your question, or still something is unclear?
No, you answered it. It's good. I get you now.
Okay. Okay, that's a good question because I know a student always confused. You're telling us signed and unsigned. Is that signed or unsigned? You got what I'm saying? I know student always confused in this point. Hopefully, I clarified it. If it's still not clear, guys, yeah, I know it's online. I don't see you, don't see me, but still we can do good teaching, right? I'm telling you, just unmute, ask me. Okay, that's how people can learn. Okay, if anything is not clear for sure. Okay, any question, guys? Okay, so let me give you the last example. Okay, so here, same thing, I give you these two numbers. I did the addition, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1, and so on. I did the addition, normally binary addition, bit by bit, normally addition, okay? And then there was a carry here at the end, so this is a carry. Again, don't be confused. The carry is not a part of the result. This is a carry, this is the result. I know some students consider everything here is the results. That's not true. Okay, this is true in digital system when you add just numbers, but here I'm not just adding numbers, I'm adding byte plus byte, and the result has to be in a byte. I'm adding register plus register. Look, the mentality is somehow different. You understand what I'm saying? So if I add just numbers, yes, this is the correct result, everything here. Okay, but if I do hardware addition, this is a register the result. That's what I will get in the register, and then this is what I'm gonna get somewhere else in the carry. Okay, anyway, so let's see the flags. Now look at the result. This is the result here. Okay, is this is 0? No, it is not 0. That's why the 0 flag is 0. Okay, guys, that's easy, right? Now let's look at the result. This is the result here. This is a positive number. That's why the negative flag is 0. Because again, I'm making it very easy. Just you can copy the most significant bit here. Okay, here. Okay, so and now look. Let's look at the carry flag. There was a carry? Yes, there was a carry here. That's why it is 1. Okay. Now look at the overflow flag. This is a negative number. I added it to negative number. 1, 1. I got 0. Okay. That's why there is overflow, signed overflow here. Okay. So that means, look here, guys. C is 1 and V is 1. What it means? It means that if your numbers are signed, okay, so there is overflow and the result here is not correct. If they are unsigned, so there is overflow and the result here is not correct. Let me prove that. This number should be, if it is unsigned, should be 172. So this is 172. This number here is 138. And then this number here is 54. 54. Is that okay? So it's not correct because the overflow. Because you can, if you add them together, the result should be 310. And as I said before, the limit is 255. This is my limit. So, but the result is bigger than the limit. Okay, that's why there is overflow. Now, let's move to the, if you consider these numbers signed, this number, the first number here is negative 84. And this number here is negative 118. Okay, if you add them together, you got 54, which for sure is not correct, because the correct answer, it has to be a negative 202. Okay, and remember, my limit here is negative 128. Okay, 128. So I exceeded the limit. That's why there is overflow. Okay, guys. Anyway, again, these flags are updated automatically after every instruction, as you will see tomorrow, and they are hardware. They are flip-flop inside the microprocessor. Any question in the whole chapter, guys?
I do have a question over these
Yeah.
flags.
Sorry, go ahead.
So when you do the addition for the bytes, all these flags are going to have some type of information, regardless if we program it to be signed or unsigned.
That's true. So you are going to get this information. Signed or unsigned is this is what the hardware is going to give you, right? So hardware doesn't know if signed or unsigned. So yes, you are going to get this information, and then in your program, are you going to look at this one or you are going to look at this one? You got what I'm saying?
Yes. Okay. And that will give us like the information that we need to say it's signed or unsigned.
Yes.
Okay.
Sorry,
cool.
say it again. The last part again.
I was just saying that those flags will let us notify that it's signed or unsigned.
Say it again. Sorry, these flags notify me if they are signed or unsigned?
Yeah, that's correct. Yeah, that's what I was saying.
No. Man, when you write your program, right, you are the programmer. You know, you already decided. This is unsigned. because this one we're gonna count the number of students. Number of students should be unsigned number, right? So you are the one who knows. You got to say when you write your program. So now you did addition. You added number of students last year plus the number of students this year, and you want to know if the result is correct or not, right? So you have to look at the C flag because you, in your code, in your program, is that clear?
Yes, yes.
So what I want to say, you have the two answers. If the number is signed, so you have this one. If unsigned, you have this one. The hardware doesn't know if they are signed or unsigned, man. So you got to say when you write your program, okay, you have to consider this. In other words, if they are unsigned, you have to check this one. If they are signed, you have to check this one. But the hardware is gonna give you both. The hardware is gonna give you both. Is that
That's
okay?
what I wanted to know. Yeah, thank you.
Any question, guys? Okay. Any question on this chapter, the whole chapter? Okay. So now on tomorrow we're gonna have lab on chapter 1. Mostly in the coming lab you will see everything I already explained here. Okay. Let me see. Yeah, everything I explained you will see it. Okay, let me. And also we're gonna have a quiz. I also, as you know, I sent you email. I posted first assignment. Okay. Okay. Now I'm gonna start the chapter 2, guys. Okay. So just let me. I want you to know that in this chapter, I'm gonna teach assembly instruction. So I structured this chapter this way. In the very beginning, I'm going to talk about the program structure, how the structure of the assembly program. And then I'm going to talk about data transfer instructions, the instructions that are used for data transfer, arithmetic instruction, how can you do branch and loops, shift, rotate, how can you do logic instruction, and bit manipulation. And then I'm going to talk about stack, why you need stack, what instructions I use for stack. Finally, I'm going to talk about subroutines. Okay, so these all the instructions, assembly instruction I'm going to teach. So I'm going to start with the first one here. Okay, guys. So as you see here, the assembly program, your assembly program should have directives and commands or instructions. Okay. So I want to tell you what is the difference between directives and commands or instructions. Okay. Directives, they are actually instructions to the assembler. They are not instruction to the microcontroller. So these directives are not going to be, so they are commands to the assembler. You are telling the assembler, when you convert my program to machine code, please do these instructions. Is that okay? So they are not going to be converted to machine code. They are not going to run by the microcontroller. Is that clear? However, the commands or instruction, these are going to be converted to machine code. They are going to run by the microcontroller. Actually, you remember last time I told you we have a table, this table instruction set. Yeah, so these are all the instruction set. I'm going to, like, for example, you want to add some number, you want to subtract, but directives, they are used to define variables. Okay. They are used to tell the assembler where you want to store your data, where in memory you want to store your program. Okay, so after you convert your program to machine code, you are not going to see the directives because they are commands. You are telling the assembler commands to the assembler, not to the microcontroller. So here in the beginning, I'm going to start with directives. I'm going to explain what directives we have, and then I'm going to start explaining commands. Okay, guys? Okay. Any questions that clear? It's going to be more clear now, but if it's not clear, you can ask me. Okay. So now, let's start with with directives. The first directive I'm gonna teach, it is called org, O-R-G, or origin, okay? So this directive, it is used to tell the assembler where in memory you wanna store your program, where in memory you wanna store your data. So usually the program our program should have at least 2 org, as you see here, guys. One org, for example, here I'm gonna say org 1000, and then you put your data here. What do you mean by data? I mean variables, I mean arrays, everything should be here, okay? And then you can say org, for example, 4000, and then your program, your code is here, program is here, okay? So what this means? It means you are asking the assembler, okay, to store your data here is in memory starting from 1000. So your data here is gonna start. So org here, this is the beginning. So you're gonna start from 1000, and then your data are gonna come here. So if your data here needs 100 bytes, so it's gonna be 100 bytes from here. Is that okay? And now the second one here for your code, where you wanna start, where you wanna put your code. Is that okay? So this is how the assembly program should look like. You have 2 parts. One part here, as you see here, guys. Let me use laser again. So we have this part here. This one and this, all your data definitions array should be here, and then your code is here, your program is here. Is that clear? So this is the beginning. I'm gonna start from 1000, and then you are gonna go this way, okay? Here I'm gonna start from 4000, and then I'm gonna go this way for your code, okay? So your program should have at least 2 orgs as explained here. So org instruction is gonna tell assembler where the next data has to be stored, starting from this memory location. Is that okay? Someone can ask me, why these magic numbers? Why 1000 and 4000? Okay, I'm gonna tell you. Is there a reason? Yes, there is a reason. Number one, as you can put your program anywhere. You can put it anywhere. It's up to you. But I like these 2 numbers. Why you like these 2 numbers? Because 1000 is the beginning of our RAM. Remember last time I told you our microcontroller has a RAM, also it has a flash memory. So our flash memory starts from 4000. So I want to store the code here in the flash memory area, and I want to start my data here in the RAM area. Is that okay? But you can write whatever you want to write, but it's not recommended to do that. It's better because I want to use the whole RAM. I want to use the whole RAM for data, and then I'm going to use the whole flash memory for your program. Okay, guys. Okay. So this is what you are also will see tomorrow. In all the assembly instructions should have at least 2 orgs, as you see here, one for data and one for comments. Okay. Number 2. Also, directives are used to define variable, like what you did in C language, right? Also, you can define variable here, okay? So just remember in C language, you remember when you did something like that, integer I is equal to 2, okay? So here you define a variable. This variable is called I, and the type of this variable is integer, right? And this variable is uninitialized. There is no initial value, okay? Here, when I say integer I is equal to 2, okay? So here you define a variable, you call it I, okay? And this I is integer, and it has initial value 2, initialized with 2, okay? We're going to do the same thing here in assembly. We're going to do exactly the same thing. Also, remember, when you say integer I, I'm not sure if they told you in C language that when you do that, so there is a physical memory location, okay? So there is a certain memory location, it is going to be called I. So every time you write to I, so you actually is going to write for a physical location in memory, okay? That's what you will see better in assembly for sure, okay? So now let's see in assembly. In assembly, we don't have integer. We are very simple. We are hardware, so we are very simple. We are not going to have integer, float, long, short. We are not going to have all of that. We have only 2. byte and word. So you can define variable byte or variable word, okay, as you will see right now. Also, you can define them initialized or uninitialized. That's what I'm going to teach right now. How can you define a variable, byte or word, initialized and uninitialized? Okay, guys, any questions? Okay. Also, I'm going to teach how can you define arrays. Just I want you to remember what is the difference between variable and the array. Big difference for sure. Okay, so variable, it's, for example, it's only one value. For example, temperature, pressure, motor speed, whatever, only one value. Okay, however, array should have several values. Okay, so for example, this is the grades of ECE 3130 students. So this is the grade of the first student, this is the grade of the second one, third one, and so on. So it's more than element, more than one value, more than one variable, right? And they are together. Why they are together? Because all of these are values for grades, for example, okay, and so on. So I'm going to teach how can you define variables and arrays. Okay, let me, yeah, now let's start with byte. Now I'm going to start how can you define byte, variable, and the arrays. Okay, and I'm going to start with initialized. It should be written this way, guys. Okay, here first you have to put a name, first a name, like for example I, some, speed, whatever, any name, right? Similar to what you did in, similar to what you do in any programming language, just any name. Is that okay? And then here, this you have to write this instruction or directive, to be more accurate. Directive dc.b. Okay, define constant byte dc.b. Okay, by the way, it is called constant, but it's not a constant value, it's a variable. Okay, or you can write dc.b, but also the assembler can accept db or fcb, so they are the same, but you can just use this one all the time. That's okay. So now it's a name of the variable, dc.b, b for byte. Okay, and then I'm going to put the initial value here, for example 5, 6, 7, whatever. Is that okay? Very easy, right? This is how can you define a variable I, which is a byte, and this is the initial value here. Okay, so, and all this definition should come in the data area. I told you in your programs there should be two areas, one area for data, one area for the code. Okay, so in the data area, for example, here I'm going to say org 1000, and then I'm going to make the definitions here. For example, I can say sum dc.b 5 I. So here I defined a variable. This is the name of the variable sum. It's a byte, and the initial value is 5. Is that okay? Also here I dc.b 7. So now I'm defining a variable. I'm going to call it I. Okay, and this initial value is 7. Okay, also I can say j dc.b 700. Can I do that? No, you cannot do that. Why? Because this is a byte. Byte, your limit is 255. You want to put 700. You got what I'm saying? Yes, the format is correct, but this value cannot be in a byte, so it's wrong. It shouldn't be 700. Is that okay? This number in decimal, this number in decimal, you still also can write. You can write also numbers in any other format. So here k dc.b, and then I put $sign here, so that this one is hexadecimal, or you can write it in binary. It's still okay. Okay, guys? So any question? It's very easy. All what you have to do, if you want to define a variable, okay, number one, you have to write it in the location, in the data area. This number one, because there is one area for data. So number two, just to put here, this is if it is initialized. I'm going to explain what if it is not initial. If it is uninitialized, how can you do it? But let's finish this one. Okay, so here name, okay, and then DC. The way you have to select a name similar to what you do in any programming language. You should not start with number. Okay, there should no spaces here, similar to any programming language, right? Otherwise the assembler is going to give you error. So here dc.b 5. That's it. You got what I'm saying? Any question?
So you said that there are spaces or there aren't spaces in
No,
between
no
everything?
spaces. Similar to any programming language, there are no spaces. Okay. If you wanna put two words, you have to put between them underscore or hyphen, but you should not leave space. Is that clear?
So I'm still a little bit confused. So between sum and DCB, there's no space.
No, that's not what I'm saying. No, there is a space
Oh, you mean
here.
for just the names?
Yes.
Okay, that makes sense. Yeah, that
I'm
makes
talking
sense.
about the name, how you select
Like
the
in
name.
C and MATLAB and stuff. Yeah.
Yes. In all programming languages, they don't allow you to leave space in the name here. But yes, you have to leave a space here. Okay. Thanks for your question. Okay, because I clarified it. Okay, guys. So now, let's come to the next point. I told you, every time you define a variable, this variable should have a location in the memory. It's the same thing even in C language. But this was hidden from you in the C language. So in the C language, you cannot know where is the location exactly. It's difficult to know, but here you can know, right? I'm going to tell you how. So if I do something like that, how this one will be in memory? I'm going to tell you how. Look here, guys. I'm going to start from 1000. This one is going to take 1 byte. So the first byte here is going to be for sum. So sum is at 1000. I is going to be next one, which is at 1001, and so on. Is that clear? Because I start from 1000. Okay, guys? So now I can even know where is the physical location. So in your program, if you want to read sum, you actually is going to read the physical location 1000. If you want to write some value, a value to sum, you actually is going to write to physical location 1000. Is that okay, guys?
Yeah, I have another question about.
Yeah,
oh, sorry.
sure.
Someone else had a question. Go ahead.
So what we're talking through right now is throwing the variables into an array.
No, this is not array. Here, thanks for the question. I didn't, here, this variable. That's why this one has one value, okay? So this is a variable, it's called sum, I, J, K, F. I have a number of variables. This is not an array. You know what I'm saying?
I'm saying, would you plug those variables into a spot that would be an array?
The way it is stored in memory, this is how it will be stored in memory. You got what I'm saying? But they are going to be stored next to each other, but it's not an array. You got what I'm saying? So in my program, I'm gonna read sum or write to sum. I'm gonna read I or write to I. You got what I'm saying? And they are two different things. Okay.
Okay.
Arrays, there should be, for example, I have array of grades. So all of them should be grades. And I have to read element by element. But here, every element has a name. So this is a variables. Is that okay? I know what you confused you. What you confused you because I'm going to store them in memory. Here I'm showing you when you make this definition, how they are going to be stored in memory. Because everyone here should have a physical location. Okay? So when you saw them next to each other this way, you thought this is array. No, this is a variable. Is that clear? Okay.
Yeah.
Okay. Other question?
My question was the define constant byte DCB is the reason why it says constant because the location is constant.
Oh, I don't know why I don't know. This is just for example, you can use DB define byte. You got what I'm saying? But there is no the word constant. It doesn't have any meaning. You just doesn't have any meaning. But always, even in C language, when you define a variable, this should have a constant location. You got what I'm saying?
Yeah, because it's physical. It's not going to be just jumping around wherever.
It has to. You cannot jump around. It has to be a physical. Every time you want to write to I, you have to write to the same physical location every time you write to I. You got what I'm saying? So just a name. You can use just define byte. It doesn't have any meaning. Okay. So any question, guys? Okay. So I want to tell you something. So now I explained to guys how can you define byte variables initialized. Number 2, I explain when you define them this way and you put them under org 1000, which this is the area for variables. Okay. So all variables should be defined in this area. I told you I have 2 areas, one area for data and the other one for codes. You should not define variables in the code area. Okay. One more thing here, what I'm saying, also I explain if you define them this way, how they are going to be stored in memory. Okay. So in your program, if you write sum, Or if you write location 1000, they are exactly the same thing. You got what I'm saying? If I write I, or if I say I want to read I, it's the same thing. If you say I want to read 1001, it's exactly the same thing, right? But it's easier for us just to use the words. It's easier because I don't need, because this is a very simple example. What about you if you have too many variables? Should I count? This is 1000, this is 1002, 3, 4, 5, and then you don't need to do that. It's easier for you to use the English word sum. I want to read sum, I want to add sum, multiply sum by 2 instead of using numbers. Okay, guys. However, when it is converted to machine code, the assembler is going to replace the English words with the corresponding addresses. So every time you write sum in your code, when it is converted to machine code, the assembler is going to replace it with 1000. Okay. Same thing for I. When you say I, assembler is going to convert it to 1001. Is that okay, guys? So it's easier for me to use English words. However, you should understand when I say sum, assembler is going to replace sum with the address. Okay. Same thing for I. Same thing for all variables. Any questions? Okay. That's why, guys, last time I told you the assembler is doing a very simple task. That's a very simple program. All what it has to do, I can do the work of the assembler, but it's just more convenient for me to write. So all the assembler is going to do is it's going to just replace my English words here with the addresses. That's it. Okay, I can do it by myself, but just it's more convenient to use. That's why I said the assembler is very simple program. Okay, now let's move to the next one. Okay. Also, I want to tell you here, guys, you know how can you write the command? In in any programming language, we write command.
Yeah.
Okay. In C language, we can do something like that, but here in assembly we put semicolon. So anything comes after the semicolon is not going to be considered by the assembler. This is just for you. You can write command this way. You will see tomorrow. That next to each instruction, I write some comments so that you can understand the instructions. Okay. Now I wanna define array of bytes, not variable. Array of bytes. Okay. So look here. Same thing. I have to start with a name. This number 1. I'm gonna use the same keyword here. dc.b is the same. Okay. But the only difference is if you put here only one value here, that is mean this is a variable and this is the initial value for the variable. But if you put more than one value, like what I did here, 7, and then this number, comma, and another number, what it means? It means this is an array, and this array should have 3 values here. Initialized array. Very easy, right? So this one is exactly similar to what I explained before. The only difference is if you have put only one value, that means it is a variable. And this is the initial value. If you put more than one value, so this is array of bytes. This is byte. Okay. So this array, initialized array of bytes, and this array should have 3 elements, right? So as you see here, guys. So this one, the first element here will be stored at 1000 because here I said org 1000. Okay. Next one is going to be at 1001. Next one is going to be at 1002. So once when the assembler is going to do that, once I read this one in my command in my program, when it is converted to machine code, so the assembler is going to put these values in memory this way. Any questions? So this is array of bytes initialized. So what I did right now, guys, I explained how can you define variable, how can you define arrays, initialized and bytes. Okay. So I'm gonna now explain how can you define variables and arrays uninitialized. Okay. Any question? One more thing, important thing. Okay, as you will see later, guys. Now, in my program, when I use the word array, so now this array should have 3 locations, as you see here, guys. This array has 3 locations: 1000, 1001, 1002. So in my program, when I use the word array, So this one is going to be replaced with which address? So this one is going to be replaced with the beginning address, the first one, 1000. Is that okay? So let me, as I said here, every time you use sum is going to be replaced with the address. But this is an easy case because this sum is only one location, so we have only one address. But in case of array, we have 3 locations. So which one? So what I'm saying, every time you write the word array in your code, so it's going to be replaced with the beginning address here, 1000. Okay. For sure, later I'm going to explain how can you read the elements of array, how can you write the elements of an array. Okay, guys, any question? Okay. So now let's move to how can you define uninitialized byte variable and arrays. Is that okay? So now I'm going to use a different keyword. Again, remember, here I use the same dc.b, the same keyword for byte and arrays, the same, okay? But here, because this one is uninitialized, I'm going to use a different keyword. This keyword is ds.b, define storage byte. Or you can just write ds or rmb, they are the same, okay? Like define storage, ds, okay? So here again, you have to start with a name, okay? And then you have to write ds.b, okay? And then this is, remember, this is uninitialized. There is no initial value, right? So what this one here you are putting here? This one is actually, if it is a variable, you have to put 1. It means only one element, one byte, okay? So in case, if you want to define a variable byte, so you have to put 1 here all the time. Yes, this is not the initial value, okay? This is how big, it's just 1 byte. That's why it is a variable. If it is array, it has to be greater than 1. So if your array has 10 elements, so I'm gonna write here 10, where every element is a byte, okay? It's very easy, very easy. So again, if you want to define uninitialized variable or array, all what you have to do, guys, name ds.b. If it is a variable, put 1. If it is array, put how big the array, how many elements you have. Again, every element is a byte because this is array of bytes, okay? Any questions? Good.
So what was the uninitialized array command?
It's the same. It's the same. Just here the number. This number, it should be bigger than 1, right? You will see. Look here.
Oh, it says DSB. I thought it was DCB. Never mind. I thought it was the same, but yeah, it's DSB. That makes more sense.
Yes.
I get you
So,
now.
for example, let's see this example, guys. Okay. So here, org 1000. I define ds.b 1. So here I define a variable. This is the name of the variable is I. It's this one is gonna take 1 byte, right? So 1 byte, and because it's a variable, okay, and it is uninitialized. Look, next one here, array. Just again, you can use any name. Okay, guys, you can use, it doesn't mean if it is array, I have to use the word array. No, this is just any name, right? So anyway, I just use array, but you can use any name. So this is array ds.b 4. So what this means? It means I want to define array. This array should have 4 elements. Every element is a byte, okay? So once you write this, how this will be in memory? It's going to be this way. Look here. Here, just they are next to each other. I'm going to start from 1000 and then they are next to each other. This one is going to take 1 location, as you see here. So I is going to be, variable I is going to be at the location 1000. So every time you want to read I, you are going to read 1000. Every time you want to write to I, you are going to write to 1000. Is that, this is a physical location for the variable I, okay? And then after this one come. Okay, this one comes. So this one, as you see here, this one has 4 locations starting from next one. So this array should be starting from 1001, 2, 3, 4, as you see here, guys. This is array. And I put here question mark because what I mean by, I don't mean it is storing question mark, but I mean it is uninitialized. Okay, there is no initial value here. Okay, any question? Okay. By the way, next week, there will be a quiz. In this quiz, I'm going to give you something like this one here. Okay. I'm going to give you something like that. And then I'm going to tell you, show me where it is in the memory. How is going to be represented in memory? You give me this one. You have to draw this one, but I'm going to give you this one. Very easy, right? So again, every time in your program you write I is going to be replaced by 1000. Okay, the assembler is going to do that. Every time you write the word array, so arrays, it's a for location, right? It's from 1001 to 1004. So every time you use the word array is going to be replaced by the beginning address. Okay, any question? Okay, now I want to explain before I go to so now just I want very quick revision on what I did, guys, before I move to next part. What I did is I said in assembly is different from C language. We don't have too many types of variable. We have only two: byte, okay, or word. So I finished. How can you define variable and the array of bytes? I finished it. Okay, I told you for variable if you want to define a variable of byte, just to put a name, DC initialized, just to put a name, dc.b, and then put the initial value. That's it. Okay. Also, I explain if you want to do array of bytes initialized, it has to be the name dc.b, and then you have to put, this is one element. So this one is going to take 3 location, and these are the initial values. Is that okay? This is for initialized. If you want to do it uninitialized, you have to use a different keyword, which is ds.b, and here you have to put 1 if it is a variable, and you have to, if it is array, it has to be more than 1. Okay, so it depends on the size of your array. I want to create array of 4 elements. I can put here 4. So 4 here, this is uninitialized, so this is not the initial value. This is how many elements. So if it is 1, so this one means it is a variable. Okay, now I want to move to word. Okay, for word, I'm gonna repeat everything again, but listen to me. Number 1, I'm gonna use a different keyword for word. This is number 1. More importantly, look here, guys. For a byte, okay, this variable is gonna byte. It's a byte, so it's gonna take only 1 location. But if this variable is a word, so it has to take 2 locations. Makes sense, right? Because it's a word. So let me see here. So instead of dc.b, it was dc.b, right? So yeah, instead of dc.b, I'm going to use dc.w. That's it. That's it. Everything else is the same, except every element here is going to be a word. So it has to take 2 locations instead of 1. Okay. Yeah. So here, how can you define initialized word variable? Again, this is the name. For example, any name, some, whatever. dc.w. So I want to define a variable that is a word, and this is the initial value here. Okay. Here I start from 1000, but this is a word. So this one has to take 2 locations, 1000 and 1001, as you see here. Is that okay? How you store them? Because now I have 2 locations and I have 2 bytes here. This is the least significant byte and this is the most significant byte. How they are stored, as I told you last time, and this is what we're going to do in the whole course, is we store the most significant byte first. So 3A F2. And these 2 bytes are I. Is that okay, guys? Okay. Nothing new. This is similar exactly to what I explained before. The only difference is here I used W instead of C. The second difference is because this is a word, so this one has to take 2 locations. Now the question is, every time I use I in my program, I is going to be replaced by the beginning address, because you can see here, guys, this is I. I actually has two locations, right? So when I write I in my program, the assembler is going to replace it with first or second. No, it's going to replace it with the first one. So 1000. Is that okay? Okay. So now, how can you make array of words? Same thing as I explained before. Just to put a name, whatever the name is, and then dc.w, same thing like this one, and then you can put more than 1 element here. So this is array of words, and this array should have 3 values, 1, 2, 3 elements. This is the initial value for the first element. This is the initial value for the second element, and this one for the third element. So let's see how this one will be stored in memory, right? So it's going to be stored this way. As you see here, guys, again, we start from 1000. So this one is going to take 2 location. So 1000, 1001, okay? And then this one is going to start because they are next to each other. So I'm going to do this one first, and then I'm going to do this one next, as you see here. So here, if this element is going to take 2 location, as you see here, at 1002 and 3, right? This element is going to take 2 location, as you see here, 4 and 5. And this element is going to take 2 location, as you see here, 6 and 7. Is that okay, guys? Very easy. Again, what I will do in the quiz, I'm going to give you this part instruction here, and I'm going to ask you to draw this one and show me how they are stored in memory. Any questions? This is initialized, okay?
So
yeah, sure, go ahead.
You want us to make the memory, like draw up the memory locations
yes.
you have on the right? Okay,
yes,
cool.
on this part, yeah, draw this one, yeah. I just want to make sure when I read this instruction, you understand where it will be shown in memory, okay?
Okay.
That's what you are going to see in tomorrow's program. So in tomorrow's program, we have one variable. We define it. I think the name of the variable is sum, and this sum, it comes after org 1000. Okay, that's why it should be at location 1000. So if you put some value in sum, and if you go to memory location number 1000, you will find these values there. Okay. Okay.
Sounds good. Thank you.
Okay. Let's see another example here, guys. When I say, for example, org 1000, okay. Maybe a little bit confusing to students, so I wanna clarify this. Look here, guys. Org 1000 array, just a name. It doesn't need to be array, by the way, but okay, just any name. dc.w. So this is array. Okay, how many? This is array of words, and it is initialized because I use DC. And how many elements it has? It has 1, 2, 3. It has 3 elements. Okay, and in the first element is going to store this value. Second element is you are going to store this value, and the third element is going to store this value. Okay. However, the trick is you have to remember this is array of words. So this one has to be in a word, even if it is a byte. Even if the number is small and can fit a byte. You got what I'm saying? So anyway, so this is a word. This is a word. This is a word. Okay. That's why when I store this one, I'm gonna store 003A. Is that okay? Because I told you last time, it just I can write this way 003A. I can write this way, or for short, you don't need to put zeros, but the assembler is going to put it for you. Is that clear? So again, if it is a byte, if this is B, DC.B, so the 3 is going to take only one location. But this is because DC.W, that means every element here should be a word. So this one, as you see here, guys, is going to take 2 locations this way. Same thing for C7. So 7 is going to take 2 locations this way. Same thing even if you write it in a binary, okay? So if you write it in a binary this way, so actually it is, I'm going to put, this is 1 byte and this is second byte 0. So it's going to be this way. Any question, guys? Always we store the most significant byte first, and then next one we store the least significant byte. Any questions? Okay. Now, how can we do the same thing but for uninitialized? So how can you define uninitialized word variable and arrays? Very easy. Exactly similar to what I said before. Exactly similar. The only difference is here I used ds.b, right? Now I'm going to use ds.w. That's it. Okay, this is one difference. Second difference is every element here is going to take 2 locations, not 1, because it's a word. You will see right now. Okay. So for example, look here, guys. Org 1000, here I want to define a variable I, and this variable is a word. So I'm going to say I, ds.w, and then I'm going to say 1. Okay, 1 means it's one, it's going to be 1 word. You got what I'm saying? So this one is 1 word. That's always, if it is a variable, you have to put 1 here. If I put 3 here, like this one, so this is array, and this array has 3 words, right? So if I write something like that, how it will be in memory? It will be this way. Look here, guys. I start from 1000. This one is going to take 2 location because it's word, as you see here, 2 location, right? So starting from 1000, I is going to take 2 location. And then this is array. This array has 3 elements, as you see here. This is element, element, element. And every element should take 2 location, a word, right? So if this is 1000, 1001, so this one should be 1003, 4, 5, 6, 7, and so on. Any questions? Great. Okay. So this will be very close to what I'm gonna do in the coming quiz. I will give you something like that. Some of them are byte, some of them are words, some of them initialized, some of them arrays. There is no arrays here. No, we have arrays here. Okay. Some of them initialized, uninitialized, byte, words, arrays, variables, and so on. I'm gonna give you something like that, and then I'm gonna ask you to draw something like that. Is that okay? Let's see how it works, guys. We start from 1000. Is that okay? Then I'm gonna say I dc.b7. So as I said before, here I define a variable. This variable is called I, and this variable is a byte, and the initial value is 7. So this one is gonna come here. So I'm gonna take this one is gonna take one byte. So it's gonna take only this one, and this is I. Is that okay? And this one started from 1000. So every time you write to I, you are gonna write to this physical location. Every time you read I, it's gonna be in this physical location. Is that okay? Now, next one, J dc.w, and then a number here. So this is a variable. This one is a word, okay, and this one has to take 2 locations. So look how. So the next one here is gonna be two location. As you see here, I call it J. So this is J, as you see here. It should be 1001 to 1002, and then it should be 3 and EF, right? Because there is a 0 here. This is 03 is the most significant byte. AF is the least significant byte. Okay. And now, next one, array 1, just a name. There is no space here, by the way, just a name, array 1. And then ds.b and 2, right? Because this is a 2, that means this is array of 2 bytes, two elements, and every element is a byte. So that's why if you look here, guys, so this one is gonna come here. It's gonna take 2 location, right? And every time I use the word array 1, is gonna be replaced by 1003, the first element in the array. I will ask this question as well. Okay, so because we need it later, we're gonna need something like that later. Okay, so every time I use the name, this name, the English name in my code, so this one is gonna be replaced by the assembler with the beginning address of the array, because this is array that has 2 elements here. Okay, now after that I define a variable k dc.w, so it's initialized word. Okay, and this is the initial value 3a. Okay, because this is a word, so this one has to take 2 locations this way, right? Great. And then I define another variable, another array. This is array of words. It is uninitialized because it is DC, not DC. Sorry, DS, not DC. So this is uninitialized. It's array of words and should have 2 elements. So that's why these 2 elements and this is 2 elements. And every time I use the word array 2 in my code, is going to be replaced by the beginning address, which 1007. Any questions? Okay, guys. All what you have to do, guys, understand what I explained now. Okay. Also, you have some examples in the slides. This is my handwriting, but also the course slide have different examples. Just understand it. And the quiz is I'm gonna give you this part. Just give me this part. I want to make sure you understood what I have been explaining for more than 1 hour now. Okay. Any questions?
Yes. So yeah, sure. The quiz that you're talking about with this slide here, that's the one that's gonna be next week, right?
That's true. Tomorrow will be a quiz, as I said, about chapter 1. Yes.
Yeah. So this is chapter 2 quiz. This
is chapter 2. Yes. This will
be next week. Okay.
Yeah, for sure. Okay.
Sounds good. Thank you.
Okay. Any question, guys? Okay. Now I want to explain something else, something we call ASCII code. I'm not sure if you heard it. I'm quite sure you should have heard something like ASCII code before. So what is ASCII code and why we need it? Okay. As I explained to guys in the first lecture, I made it very clear. The computers, microprocessors and computers can only understand numbers, binary numbers. This is the only language they can do or they can understand. All the data should be stored in binary. Your videos, your pictures, everything is stored inside the hardware is binary, right? However, we as humans, we use letters, right? We use M, L, K, A, B, X, N, Y, F. We use letters, right? As humans. So microprocessor does not understand the A. When I type A, microprocessor doesn't understand what is A. Even microprocessor does not accept it because it only needs number. You got what I'm saying? So that is why we came up with a table. Okay, this table is called ASCII code. Okay, so what this table means? It means every time I hit one character on one number or one letter, anything on the keyboard, this one has to be translated to a number, right? Okay, this is what we call the ASCII code of A, right? So this is like the other version of A. I have to convert A to number, right? L to number, K to number, and so on. Every key here should have a number. That's what we call the. So every key on the keyboard should have ASCII code, and this code. So when I press A, actually I'm gonna send number 40 to the microprocessor, okay? And we are gonna do the opposite here. When we send the 42 to the monitor or to the LCD on our board, you are gonna see letter A. You got what I'm saying? Because the hardware here is designed when I get 42, I have to display A. Is that okay? So if you go to the slides, let me show the slides. Okay, guys, can you see this table? So here, this is what I say ASCII code. Okay, so anything we have on the keyboard, so even plus, look here, plus should have, this is the ASCII of plus. That means when you hit plus, this is the value that should go to the microprocessor. If the microprocessor want to display plus on the LCD or on the monitor, it has to send to 2B, right? Same, so everything, even space has a number here, even space, right? Equal, even numbers. Look here, guys. So 0 is gonna, you actually when you hit 0, you're not gonna send to 0. You're gonna send the ASCII of 0, which is 30, 1, 31, 2, 32, and so on. Is that okay? Same thing for. Remember these numbers because we're going to use it. It's easy. We're going to use it. So 0, 30, 31, 32, 30. So this is the ASCII. Okay. Also here, if you see uppercase letters A, it's a 41 for A. Is lowercase is 61, as you see here. 42, 62, and so on. Okay, guys. So, any questions?
Yeah. Do you take attendance in this class? Because a friend of mine just messaged me that his Wi-Fi went out.
No, I don't take attendance. I take attendance for labs.
Okay, sounds good. Yeah, he was just talking about for today because he lost Wi-Fi.
That's okay. I'm recording the video, also the lecture, and I'm gonna post it online so he can watch it. Okay. Anyway, so why I explain this, guys? Because sometimes you wanna define a message. Sometimes you wanna define a message so that you can display it on the LCD. You wanna use it later. Okay. For example, we have a directive here. It's called FCC. So FCC is used if you want to define a message, something like that. Look here, guys. How can you do it? You can write a name here. That's what I said before. Error MSG, right? Error message. So here you have to put underscore. You cannot leave a space here. Okay. So this is a name, and then I can say FCC, right? And then I can put quotation, as you see here, quotation, right? And then you can write the message, whatever you want to write. Error, and then try again. Is that okay? So this is how can you define messages so that you can use them later to display them on the LCD, for example. Okay. So the question is how these messages are gonna be stored in memory. Okay. So starting from this location, we are gonna store the ASCII code of each character. So this one is going to be, I think I have another example. Yeah. So look here, guys. I say org 1000, a name, any name, alpha, FCC, quotation, GEF. So this is a message, GEF. So when you do something like that, you define a message this way, assembler is going to store it this way. Starting from 1000, this is the ASCII of G, this is the ASCII of E, this is the ASCII of F. In other words, the message is like array of bytes. It is like, yes, it's like array of bytes where every byte is actually the ASCII of one character. Is that clear? Okay.
So the FCC, is that the command for?
That's true. This is a command you have to
Okay.
use. That's true. Okay. So this is one of the things the assembler is gonna do. That's why I told you the assembler is very simple. So you can just write English words this way, and the assembler will help us just to convert it to ASCII code this way. Okay. So if what I want to say, guys, this one I can write this way. If I say alpha dc.b, you define array of bytes 64, 65, 66. They are exactly the same. But the question is why I bother myself and go and see what is the ASCII of every character? You can just put it this way, and the assembler is gonna convert it to ASCII code this way. Any question, guys? That clear? Again, just quick summary to define a message. Write the name of the message, command, FCC's command, quotation, and then write the message here. How this one will be stored in memory? This one is going to be array of bytes in memory. Okay. So what's going to happen? Every character here is going to be stored in its ASCII, right? The next directive I want to teach, we call it equate, and you will see tomorrow as well. Equate. Okay. EQU. So what is equate? Okay, let me explain the similar one in C language. Hopefully you remember it. Okay, and then so in C language you can do something like that. Define hashtag define speed 20, right? So define is a command. Okay, speed, this one can be any name, and this can be any value, right? And then okay, what this command is doing in C, because equate is exactly the same thing. Okay, what this one is going to do, I'm going to tell you. Now in my program, I can use the word speed. Speed plus 5, speed divided by 2, y equal speed. So I can just use the word speed. And then when it is converted to machine code, what's going to happen? The compiler is going to replace speed with this number here. Is that okay? So again, for me, I'm gonna see the word speed in my program. I'm gonna use the word speed. However, when it's converted to machine code, all the word speed used in my program is gonna be replaced by this number 20. Okay, but why you do that? Why you don't just write 20 20 20? Okay, actually there are two reasons. The first reason is better readability. When you read the program and you see 20 20 20, you may not understand. So it's for human. When I read your code and see 20 20 20, I may not understand what 20 means. But when I see the speed, oh yeah, so in this equation you are using the motor speed, yeah, and then you divide the speed by and so on. So this is for better readability for human, for us. This is number one. The second advantage is easy to change. For example, guys, I want to try my code when the speed is equal to 20. I can just put 20 here in one line, and then I'm going to use the speed everywhere. And then I changed my mind. Okay, I want to try 30. No, 20 didn't give good results. Let's try 30. Okay, so here I'm going to change only one location instead of going everywhere to change 20 to 30. Okay, this is the two main reasons why you can use equate this way. Okay, guys. We have similar to equate here, but we have something is called equate. Similar to define, we have something here we call equate. Okay. Also, this one also can be used if you want to define constant. For example, by. You can define by 3.14, right, and so on. Speed of light, or speed of voice, or speed of ultrasound, whatever. So you can define some constant, and that's what we're going to do all the time. We're going to use equate to define some constant. So how we are going to do it in our program? Number one, this is how you have to do it, guys. You have to, this is the word, whatever the word is, you have to use equate and you use 50. That means you are telling the assembler, please, every time you see the word speed in my program, replace it with 50 when you convert it to machine code. Is that okay? So here, is that okay? So just a name, equate, and then you put a number. So assembler is going to replace this name with this number. The second point, where I have to write this one, right? Where? I told you we have one area for data, org 1000. This area for data, we have area for instruction, org 4000. So this is 4000, okay? So this area for code, this area for data. So this one, where I have to put this one? Actually, this one has to be outside here. So it should be before this org. So it should not put it here because this one is not a location in memory. This one is not going to be in memory. So this one has to be, we have to put it outside here. Any question, guys? Okay. The reason we are going to use it, let me see what's the time. Oops, okay. Just give me 1 second. The reason we are using it, guys, because there are some addresses. Okay, you don't need to remember. You will see in next chapter there are some addresses. You don't need to remember the addresses. So I'm gonna put here some English names, and then I'm gonna put the addresses. And all what you have to do, just use English names instead of remembering. You don't need to remember numbers. It's hard, but it's easy to remember English names. Okay. The last one quickly. I wanna explain here because yeah, by this one I'm done this part. So the last one here is called fill. We're not gonna use it a lot, but I'm gonna tell you how it works. For example, I can use fill, okay, and then I'm gonna say this number 20 in 40 locations. Look, so this one is used if you wanna fill some value in many locations, something like that. So if I say fill, so that means you have to write number 20 in 40 locations starting from 1000. So I'm gonna start from 1000. I'm gonna store 20 in 40 locations. That's it. So I don't think we need it, but just in case you want to put zero somewhere or something like that, just in case. Okay. Any question, guys? Okay. Okay. So see you tomorrow, guys. Okay. Bye.
I got a quick question.
Yeah, sure.
Where? Sorry, I cut out. Where is it on the website that we can go to download the program?
Okay. Open the lab. If you open the lab sheet, I give you a link inside the lab. Okay. Okay. So you just use this link to download the program. Is that okay? Hello? Are you there?
It's
Yeah.
under 7. You got like the
Yeah.
resource, not resources, 6 labs. You'd have all your different lab PDFs.
Yes. So open lab 1. Okay. It's written all the instructions are there for lab 1. Is that okay? Also, and I forgot to tell you, if your computer is Mac, because this program should run under Windows, also I give you some solution for this problem. Okay. Just read the lab and we can help you to do it. Okay. But I think I said in the lab you can have like a dual operating system, or you can make what's called virtual. There are some programs you can download to make virtual Windows under Mac. Okay, guys. Okay. So see you tomorrow. Goodbye, guys.